Okay, hey guys, this is take two of the week 9 Monday assignment here, the lecture. First time I tried to do the PDF on a separate tab and I realized that it wasn't actually going to Excel at all when I was clicking back and forth, so I went and put it right inside of the Excel sheet here. So to start off here with the main topic of this section is going to be learning how to use the Excel solver to solve these LP problems we've been doing all semester. So along with that, we introduce a fixed charge problem, which basically just deals with situations where you have an initial flat fee, which is going to be basically something that doesn't change based on the number of the quantity that we apply to our variable. So in a situation like this, we have our cost C of x is equal to F plus C of x, where F is that fixed cost that I mentioned, and then C is going to be our unit cost, our coefficient, and x is going to be varying based on our production level. So in this situation, it's going to work exactly how you'd picture it, with how we've been doing them before, with a coefficient plus that fixed cost. And then if our x value is 0 and we don't have anything here, our f is not going to be applied, so that's why it's piecewise and we have the 0 down here, because if x is equal to 0, then f is also going to be 0 and you're going to get charged a total of $0. So going into our first example here, I have been approached by 3 telephone companies to subscribe to their long-distance service in the U.S. Nobel will charge a flat $16 a month with 25 cents every minute. PA Bell charges $25 a month, but the per minute cost is only 21 cents. And Sobel is an 18 per month charge, and then the cost per minute is 22 cents. It says that we usually make an average of 200 minutes of calls every single month, and assuming that the fee is only applied if we use the company, how should we make the arrangement of our plan here? So we're going to assign x1, x2, and x3 to our 3 plans here accordingly, and this whole paragraph here basically just explains how to make our coefficients and stuff. So our objective function is to minimize z, which is 25 cents times x1 for our first company, plus 21 cents times x2, plus 22 cents times x3, plus our binary variables here, y1, y2, and y3, with the fixed costs for each of the 3 plans here, 16, 25, and 18. Then we have our constraints below, which we are going to say y1 plus y2 plus y3 equals 1. This is basically just saying that we're only going to be using one plan here, so among the 3 binary variables, it only is going to equal 1 for the one plan we use. Our total minutes, x1 plus x2 plus x3, is going to equal 200, so we get that 200 minutes that we're looking for. And then finally we have our constraints for x1 is less than or equal to 200 times y1, which is basically saying that our minutes are going to be equal to 200 basically, because if we're using the first plan, then y1 will equal 1, so this will be 200, and if we're not using the first plan, then this is going to equal 0, so x1 is bounded to 0. And then same pattern goes for x2 and x3, where it's less than or equal to 200 times y2 or y3 respectively. Then we have our non-negativity constraint, so all of our x1, x2, and x3s are going to be greater than or equal to 0, and then our binary constraint down here, so all of our y variables are going to be equal to either 0 or 1. So looking over here at the chart, I did basically just label these x1, x2, and x3 are Nobel, PA Bell, and Sobel. So we have our decision variables here. So these are all just going to start off as 0 because Solver is going to manipulate these numbers here to find our objective solution here. And then we input the variable costs. So we have the 25 cents per minute for Nobel, 21 cents for PA Bell, and 22 for Sobel. And then down here we have our binary variables, y1, y2, and y3. Again, we put these zeros in here for Excel to play with, and then we have our fixed costs of $16 per month, $25, and $18 per month. So up here is our first equation we have, which is going to be utilizing the sum product function. So with this, we are basically just doing B4 through D4 are going to be our 3 zeros up top here, and then B5 through D5 is going to be each of the cost per minute quantities. So the way this works is it takes the first entry, B4, and multiplies it by the first entry of the next part here, B5, which is going to be the minutes for Nobel times the price per minute, and then it sums that up and adds it to the sum of the price per minute times the minutes for PA Bell, and then the same thing goes for Sobel, price per minute times the minutes. And then along with that, we're also adding the fixed costs we have down here. So same thing, B7 through D7 are these zeros for all three of our Ys. B8 through D8 being the fixed costs themselves. It multiplies those out and adds it to our sum up here to give us our total cost. Then I made a second box here for the desired total minutes we're looking for, and then the resulting total minutes we're getting just from summing the three decision variables up here. So ideally this is going to equal exactly 200. At the very least, it's going to be at least $200. Now, if we flip over here, I did implement the constraints as well into Excel. So for our x1, x2, and x3, we do have our first constraint, which is x1 plus x2 plus x3 is going to be equal to 200, which is actually already solved because I didn't reset it, but that's okay. Our x1 constraint is going to be less than or equal to 200 times y1. This is going to be, again, only if y1 is active. This is going to be applied. And then for x2, we're going to have it less than or equal to 200 y2 for the minutes. And then same thing for x3. x3 is less than or equal to 200 times y3. Again, only if that y3 plant is active. If not, this will be 0, and these are going to be bounded to 0. And then finally, our binary constraint y1 plus y2 plus y3 is equal to 1 here. It's because we only need one plant, as I mentioned before. So once we have this all set up here, which actually I'll show you guys as well here, these are all going to be set up as sum products as well, where this is going to do the sum product B4 to D4, so our x variables up here, multiplied with A13 through C13, so these three constraint values, and this gives us our values that will meet our bounds. Again, these are all just adjusted for the same x values multiplied by the constraint line that it's in. And we go ahead and go up to Solver now in this top corner. It's under the Data tab in Excel. Click this, and we get this nice little box that pops up here. Our objective is going to be G1 here, just where I put that sum product equation from earlier. We want to flip this from max over to min, because we're minimizing the cost. And then we put in which cells are our variable cells, so Excel knows what it can change, which is going to be B4 through D4, right up top here where these zeros were, and B7 through D7, right below it for these binary variables. Then we input our constraints. So for the binary constraints here, I'll go ahead and show you guys how to put this in because it's a little different. I'll just remove this. We go ahead and hit add. And whatever cells we're going to put the constraint on, in this case it was B7 through D7. These ones we just want to make sure they're binary, so these only stay 0 and 1 because you can't buy multiple plans or anything of the same provider. So you hit bin, and that puts the binary constraint in there for you. Hit OK, and that's all set in there. And the same thing in general goes with these. You just hit the add, go in, and you put whatever cell you're going to put a constraint on here. You can change this from greater than or equal to, less than or equal to, or equals, and then whatever it's bound by on the other side. So I did go ahead and put in the constraints for, again, the binary D13 equals E13, which is going to be right here. We want the 200 total minutes here to be equal to our bound of 200. We want D14 to be less than or equal to 200 times B7. So this again is going to be where we're talking about x1 is only active if y1 is active, so we're doing 200 times y1, which is again this b7 up here, and that just makes sure that we have minutes on x1 only if we purchase the plan. So we do that for all three of the plans, and then lastly d18 equals e18 is going to give us our value here for the sum of the binary variables here with y is equal to 1. So again, this is just only need one plan. That's all that really means. So we check this box down here to implement our non-negativity constraint. All this is just a little checkbox. It keeps our x values positive. And then this starts off on GRG nonlinear. We flip that over to simplex to make sure we're using the right algorithm. Hit solve. And once this all pops up, again, this would have been zeros and implemented these before, but since I had already solved it on my first attempt here, it didn't change them. But again, this does tell you our objective function here. Our lowest cost is going to be $62, and that's from using plan 3 here for all 200 minutes. And again, it does show us that our total minutes are exactly what we wanted in our desired total minutes. Which this is interesting because it kind of shows how the simplex shows things you might not notice. In this case, Nobel had the lowest fixed cost, PA Bell had the lowest per minute cost, but actually it was Sobel that ended up being the cheapest in the end, kind of in the middle of both of those categories. So we can go ahead and jump to the next problem here, which is the widgets problem. Jobco is planning to produce 2,000 widgets on 3 machines. The minimum lot size on any machine is 500 widgets. And here's the table that kind of gives us the data. So this one's a little bit different than the other problem because now not only do we have upper bounds, but we have a lower bound as well, with the minimum lot size being 500 widgets. So we have our 3 machines, 1, 2, and 3, our cost to activate the machine, and then the cost per unit over here. So, and then we also have upper bounds with our capacities here. So I did kind of right on the side, our number of units produced is going to be our x's here, just goes with the 2, 10, and 5. And then our binary variables are going to be all 3 of our y's, which are just associated with those fixed costs that we mentioned. So with our objective function up here, we're trying to minimize the cost, and we're going to have 2 times x1 plus 10 times x2 plus 5 times x3, these all being straight from the production cost, plus 300y1 plus 100y2 plus 200y3 for the 3 machines. That's just the fixed costs again. And then this is all subject to our constraints of x1 plus x2 plus x3 is greater than or equal to 2,000, which is just our production constraint. We need to have at least 2,000 widgets based on the problem. And then these are going to be bound by our minimum lot size on the machine and then our capacity for each machine here. So 500y1 is less than or equal to x1 less than or equal to 600y1. Again, these y's just kind of activate the problem or the constraint only if the machine is used in the problem, because these are always going to be 0 or 1, so that's why they're attached there. Then 500y2 less than or equal to x2 less than or equal to 800y2. Again, that lower bound 500 and the upper bound 800 from the capacity. And then for machine 3, 500y3 less than or equal to x3 less than or equal to 1200y3. Then we have our non-negativity constraint, of course, x1, 2, and 3 all greater than or equal to 0, and y1, y2, and y3 are all going to be binary. So here we do have the table set up from that, where we have machines 1, 2, and 3, and then x1s, which again they start off with the zeros, and then we have our variable cost straight from the problem, 2, 10, and 5, which are right up here. Then we have binary variables, which all start off as zeros for our 3y variables, and our fixed cost for the activation of the machine, $300, $100, and $200. So with our objective function, it's set up the same way with sum product, B4 through D4 times B5 through D5. This is giving us our this part of the product up here, all 3 of our zeros for our decision variables times our variable costs, and then plus the sum product of all of our y variables times their respective costs. And here we're looking for 2,000 total minutes or widgets, and this is going to give us the resulting widgets here once we finish it. So flip over to this next sheet, and we do have the constraint table in here I put in. So basically we're just looking at we have the first constraint, which is x1 plus x2 plus x3 must be greater than or equal to 2,000, which is just for the total widgets we're shooting for. With our machine bound, we know that x1 has to be greater than or equal to 500 y1, assuming we're using the machine. But it also has to be lower than 600 because that's the maximum capacity for the machine. For x2, we do have the lower bound again of 500, and then the upper bound here of 800. And then for x3, lower bound 500 yet again, and upper bound of 1200. So once we go ahead and put this all in Solver, we have our objective function up top, which is G1 in my case. We're minimizing cost yet again, and we have our variable cells put in, B4 through D4, B7 through D7. Again, these are just going to be where we had those zeros on that other sheet. And then we have our constraints, which we have binaries for B7 through D7, because these are only going to be charged once, as they're the activation fee. D12, we want to equal E12 so that we get 2,000 widgets in there. Then we have D13 is greater than or equal to 500 times B7 and less than or equal to 600 times B7. So, and this is D14 for the next line here. This again is just putting in the upper and lower bounds for machine 1. Then the same pattern goes for machine 2 with these 2 constraints, and then for machine 3 here. Finally, we do check that box to make the non-negativity constraint active. Make sure this is put to simplex and hit solve. And then magically this will give you our optimal solution, which in this case is going to be a cost of 11,300, where our x1 variable is 600, x2 is 500, and x3 is 900. So here we're using all three of the machines, so all of these are ones and there's no zeros. And then finally our third problem here is going to be the oil problem. So we have 2 drilling sites and we're trying to reach 4 total targets, and this table kind of gives the preparation costs for the 2 sites. So for site 1, if we drill from site 1 to target 1, it's going to be $2 million. Site 1 to target 2 is going to be $1 million. Site 1 to target 3 is $8 million, and then to target 4 is $5 million. And then from site 2, target 1 is $4 million, to target 2 is $6 million, to target 3 is $3 million, and to target 4 is just going to be $1 million here. And then we also have the prep costs for these sites. So we have $5 million for site 1, $6 million for site 2. So then forming the problem down here, we're again just minimizing cost, and I kind of used matrix notation here to indicate which coefficient we're talking about here. So 2 times x sub 1, 1 is going to be this site 1 to target 1, and it kind of follows that pattern, plus 1 times x sub 2, 1, plus 8 times x sub 3, 1, plus 5 times x sub 4, 1, plus 4 times x sub 1, 2, plus 6 times x sub 2, 2, plus 3 times x sub 3, 2, plus 1 times x sub 4, 2. Then we also have the binary prep costs over here, plus 5 times y1 plus 6 times y2. And that whole sum is going to give us our total cost here. Then for our constraints, we have a constraint for each of our target because it needs to be connected to at least one of our sites. So x11 plus x12 is greater than or equal to 1. This is saying that we have to pay basically for either site 1 to target 1 or site 2 to target 2. And the same pattern goes for the other 3 targets. X sub 2, 1 plus x sub 2, 2 greater than or equal to 1. X sub 3, 1 plus x sub 3, 2 greater than or equal to 1. X sub 4, 1 plus x sub 4, 2 greater than or equal to 1. Then we have, this is just for our activation fee here, x sub 1, 1 plus x sub 2, 1 plus x sub 3, 1 plus x sub 4, 1 is less than or equal to 4y1. So this just says if we're using site 1, we have to account for all of that. And then for site 2, it's x sub 1, 2 plus x sub 2, 2 plus x sub 3, 2 plus x sub 4, 2 less than or equal to 4 times y2. And then last but not least, in this case, we actually have all of our x's and our y's binary because you're not going to make more than one path from a site into the target. So it's either 0 or 1 for those. On to our final sheet here. I put the constraints in for us, which actually I didn't even mention our values up top. I'll go back really quick. For this situation, because we had kind of a different setup, I did all of our x1 under this big heading here. So from site 1 to target 1, it's going to be 2 million, and then so forth for targets 2 through 4. It's 1, 8, and 5 million. We have that row of zeros up top because this is what Excel is going to change. And then yet again from site 2 to target 1, it's 4 million, and then 6, 3, 1 for targets 2, 3, 4. And then for our preparation costs, we have the zeros up overhead again, and our fixed cost is going to be 5 million to activate site 1 and 6 million to activate site 2. So going ahead now with our constraints, we have that x1 plus x2 is going to be greater than or equal to 1 to make sure that we're bound to meet target 1 at least once. Obviously it's going to be only once in this case because it would be a waste of money, but it could be an equal sign if you'd prefer. x1 plus x2 greater than or equal to 1 for target 2, and then so on and so forth for targets 3 and 4. And then we have our constraints for our binary variables y1 and y2. For y2 is going to be greater than or equal to 1 to make, or less than or equal to 1 to make sure that we meet the preparation cost. And then y2, the same thing, less than or equal to 1 for the second prep cost. Again, we have that objective function up here with our sum products. In this case, I did 2 sum products for each of the y constraints because they weren't lined up, so I couldn't use the colons. Then we go ahead and jump into solver again. Put our objective function cell in there, make sure it's set to minimize that cost. We put our variable cells in, so all of our zeros we had, B4 through I4 is going to be this row, and then we have C7 and G7 for these two cells right here. Then we have our constraints again, so we have, since in this case our x's and our y's are binary, we have all of our x's here set to binary, and then y1 is binary, y2 is binary as well. And then for down here I just said that each of these constraints we mentioned before was equal to its bound, which is just one path is all we need. So again, make sure the variables are non-negative and we're set to simplex, and then once we do end up running that, we get our result here, which is from site 1 we're drilling to target 1 and target 2, and site 2 is drilled to target 3 and target 4. So we're using both sites here actually to minimize the total cost, and that ends up being 18 million for this situation. So that's about it, guys. That's how to do Excel Solver for the first section. Thanks for listening.